Uh, so we have come across garbage collection and many other different data structures. So also we covered about the object oriented concepts in Python. So there will be few more videos regarding that, but in today's video our main discussion is about the stack data structure. Now if you have a programming background again from C or C++, there you might have used stack and queue, then dequeue, then there are many other data structures that are present. But first of all, when I talk regarding the data structure in Python itself, it itself has few of the data structures, that is list, string, tuple, then set, dictionary. These are the basic built-in data types that are found in Python. But as I said, Python has a very rich library and has extensibility to provide or create new data structures or any other existing data structures which are seen in other programming languages. So when we talk about the memory management that we have done in the past two videos, uh, there whenever we want to allocate some object to some memory, we need to create a memory model. So basically in the literature or in programming literature, whenever you take any books or read on any blogs or sites, you basically find stack. So stack is one such primitive linear data structure which stores the elements or the objects in a fashion. So that fashion is basically called as LIFO. So that is LIFO. LIFO stands for last in, first out. So last in means whichever element uh, went in last into the stack, it will pop out first or it will get out first. And there is another name. So this is also just the opposite to LIFO, that is FILO, that is first in, last out. So whichever element went first, it will be popped out last. So if you are just confused with these terminologies, no worries, I'll just explain these things out. So stack, as I mentioned before, it is a linear data structure. Write DS, that is linear data structure. So basically whenever you want to insert elements into this stack data structure, uh, it can be only inserted or deleted only from one end. So as you can see, there is only one particular end, that is this end you can see, where the elements can be inserted and elements can be popped out. There is no other way you can remove this. So obviously you may think like you can just put a finger and like pop the elements in between. So that we are not considering, that is an exception. So we are just considering about the memory allocation, how in memory this basically looks. We are discussing on basis of that. So now what happens is whenever you try to insert any elements into this. So say for example, uh, we want to put an element, say we are putting some integers. So first when we want to put an integer, say first of all consider this as an hollow buffer or hollow stack. Now if I first want to put the element 1, so it will go first here. So my 1 resides at the bottom of this. Then if I want to put element 2, it will be above 1 on top of this. And if I want to put element 3, it will reside somewhere here. So the first element that I put, that was 1, then after that I put 2, and after that I put 3. So it increases in a top to bottom fashion. So if you want to just visualize, this grows in this way. So, and this is also the pattern of insertion. Now insertion is also called as push. So insertion is signified with the help of a keyword, that is push. I'll write here, that is push. For beginners who don't know what this stack and what the stack operations are for them, and if you want to delete elements, so deletion follows this path, that in this way, and deletion is triggered with the help of pop. So this is the basic of how the element traversal is done. Traversal means how you can put the elements and how you can remove the elements. So this is the way. So now whenever you want to take out one element, or whenever you want to pop any elements out of this, so pop is basically done from the stack top. So stack top refers to this portion. So this is the stack top. And now when first element goes out, it will be this 3. So 3 will be out, and then element 2 will be out, and then finally element 1 will be out. So this basically what I've said here. So that satisfies this LIFO principle, that is last in first out. If I ask you which element uh, came last into this stack, that is this one, that is this element 3, and which element is getting out first, that is the same element 3. Now what you can do is, probably you can just tilt this stack, and you can arrange in this way, in a linear way, either of uh, way you can implement. So it is both in linear. So here you are building it from top to bottom, here you are building from uh, right to left or left to right, if you just tilt in the other position. So now the stack head is, this is the stack head, so stack head towards the right hand side, so this is to the right hand side. Now you can also put not only integer elements, but also you can put string elements. So say for example, if I have put an element, say like I have put A, then B, then C. So A came in the first, so it will be into this stack. So insertion here, it happens this way. So insertion is done in this way, and deletion or removal is done in the opposite way. This is how deletion is done. So whenever you delete the element, C will be first popped out, then B will be popped out, then finally A will be popped out. So that is basically FILO. So FILO and LIFO both are the same. So first in last out. So first element which came into this stack, that was A, it will be removed at the last. So that is the basic definition of stack and the traversal of how the elements are pushed and popped into this stack. Now when it comes to Python, there exist 3 ways by which you can design stack. So the first way by which you can design stack is by using our primitive data structure, that is list. So with list, if you remember, it has the functionality of appending and removal. Also it has the functionality of popping the elements. So basically you can use that. So append refers to push in list, and for pop you have inbuilt method pop. Now apart from list, there are 2 more methods by which you can design stack. So design principles. So the second design principle is by collections. So in collections, collection is basically a library, like how you have a math library. There is a library called as collection, and in collection there is a class which is called as DQ. So this is another way by which you can design your stack. And the third way is by using a package or a library that is called as queue. This is the name of the library, and inside this library you have something called as LIFO queue. So these are the three design principles by which you can design or implement stack in Python. So it's better that we understand this with the help of our example or coding in Python. So I have three codes corresponding to three of these design principles. Let's see one by one. So this is the design of the stack by using the list. So what I doing here? So I'm basically using a list comprehension. This you are familiar, very much familiar, and I'm taking the input from the user and I'm evaluating for that, and I'm splitting by comma, and that I'm passing on to list. So in list L I will have all comma separated elements which are ready to be pushed onto the stack. So you should use the word push and then pop. So this will print the initial stack. Initial stack will be empty. Then elements will be there, which will be put one by one onto the stack, and then elements will be popped one by one. So this implementation we are going to do dynamically. We are not going to do it statically. Means you can see there are no hard coding apart from the pop statements which we have written. So let's run this and see what output we get. So it is asking to enter the elements onto the stack. So I'm entering 10, 20, 30, 40 and 50. So I basically have 5 elements now. You can see the initial stack contains these many elements. Elements popped from the stack are 50. So it goes in this way. Just realize this diagram with the help of this thing. Like assume your stack you have put in this way, this diagrammatic structure, and so 50 at the head, then after that 40 comes, then 30 comes, and corresponding to three pop statements what you have, it just popped three elements. So 50 gets removed, 40 gets removed and 30 gets removed, and then there are two elements that is left. So this is the basic implementation of stack. Now this particular implementation in list has got certain disadvantages because internally when it just calculates or when it just implements the append function where you put the elements, like if you are doing hard coding by using the normal append function instead of this list comprehension, what happens is the memory consumption or the time it takes to execute the query or execute the command gets increased. So ideally in stack data structure, the insertion and the deletion, the time complexity that is mainly followed is of the big O notation of 1. So it should ideally have the time complexity of big O of 1. In some cases this is not followed because of the underlying data structure and the complexity of the elements at the hand. So as opposed to list, we have other two techniques that are free to use. So now we just move on to the second technique of designing the stack in Python, that is by using the collections library. So I'll just comment this out, and I have stack design using DQ. So as I mentioned before, there is another library which is there in Python, that is collections, and from collections I'm basically importing a method that is DQ, or basically a class. So DQ is another class, and inside this I'm just writing the same syntax, but here instead of like this, what I'm doing is I'll just, yeah, so instead of just passing the list comprehension, I'm passing into the constructor of the class, that is DQ, So, and before that, let me do an activity. So I just want to make sure what is the type of this L. So here you can see the type of L is list because we have used list. Now the same thing, just we are putting into the constructor of the DQ class, and just we are doing the same operation after this, whatever we have done above in list. Let's go ahead and just execute this, and say I now have the same elements. Let's take the same elements 20, 30, 40 and 50. So just this representation stack after the elements are popped, you can see it is in a DQ formatted. So inside a DQ it is maintaining this list. If I check the type of the variable name that I used is stack, so you can see the class is collections.dq. So this is how you check whether which data structure, uh, on basis of that you have implemented your stack. And this is by far the easiest way of implementation. So we have another method also, that is the third method by which you can design your stack. So that is by using the LIFO queue. Now LIFO queue is another class which resides inside the queue library. So just don't get confused with this queue and this queue. This queue is residing inside the collections library, and this is a separate library queue itself, and inside that you are using the LIFO queue. So from the name queue you should not get confused because it has a similar data structure internally, just it's the name LIFO queue. Just focus on this word, that is LIFO, last in first out. Now what I'm doing is I'm just creating or instantiating the list. So it has some additional lines of code that you need to do. So it is little different, and the methods what you saw here, that is stack.pop and append, which you saw in the this portion for DQ and list, as opposed to that it is different. So first what we do is in LIFO queue we basically initialize the stack, and at the same time we assign a memory statically. So there what happens is you are statically allocating the memory so that it does not grows in size exponentially as there in list. So here we are creating a variable, that is LIFO stack. So the name of my stack is LIFO stack, and the size of the LIFO stack that I'm designing is 3. So the maximum size is 3. This is a parameter that is there inside this class, and I'm printing the LIFO stack size. So that is queueSize method. That is a method which resides inside this particular LIFO queue. I'm just invoking to check what is the size. So the size before putting the elements will be 0. Next, consider like I want to make lemon juice. So what I basically put is I will take a glass, something like this, just to be, yeah, I will have a glass something like this, and at the base what I put is I put some sugar. So first I'll put some sugar, then after that I'll put some uh, lemon drops, then after that I'll put some water. So this is the basic principle of stack. Just a small example, instead of salt I should have put water. Okay, and as you saw, like the basic English we just spoke, put. So we basically use the put. So it is as simple as that. Put sugar, put lemon drops and put water onto this stack. So stack here will be considered as our glass. So this glass is our stack now. So again we check if the stack is full or not. So here in this case it will be full because it has reached the max size. So it has no more additional space or buffer to incorporate any new elements or any new ingredients onto this stack. And then we'll check the queue size. Then we'll just pop the elements one by one. So just remember, whenever you want to pop the elements out of the stack, it will be done one by one. It will have a time complexity of big O of 1. And for popping the elements, you don't have pop method, you have get method. So you basically use the get method, and then we'll check if the stack is empty or not. This will return true or false. If the stack is empty, it will return true. If it is not, then it will return false. We'll just go ahead and just run this, and you can see initially when there were no elements, this particular line it printed as 0. Then is the stack is full? Yes, true, because it reached the maximum size. And what is the size? That is queue size, that is 3. And elements popped from the stack is, first water popped out, lemon drops popped out, and then sugar popped out. Ideally this does not happen, just a simple example. And finally we are checking whether the list is empty. So it is saying yes, it is empty, because all the elements which has reached the maximum size has just uh, extinguished, or there are no further elements. We'll just go and just change this size, and we just again do this. So we are again checking this, the stats which we get. So full, is it full? No, because we are just putting 3 elements, that is size is 3, and we have space of 2 more elements, max size is 5. Elements popped from the stack are this much, and after the elements which are popped, is the current stack empty or not? That returns true. So this program very much well demonstrate the use of linear data structure, that is stack, which is most widely used in C and C++ programming. Python made it very simple, and it also gave you flexibility in designing in 3 additional techniques, which was by using the list, collections DQ, and q.lifo DQ. So well, that was all regarding the stack data structure in Python. So hope you guys enjoyed this video. If you found you got educated of this video, please do like, share, comment, and if you're new to this channel, please consider subscribing. Thank you very much for watching this video.